Alright, introduction to geometric roads and streets. General design consideration, geometric design for roads and streets. This publication is adopted a unified facility criteria of the United States government with the public domain authorized unlimited distribution and are not copyrighted. General, the purpose of the publication discuss the geometric design criteria for the road and street with the set forth the approach of the traffic flow, critical with the guidance of determining types of configuration best suited for the construction. Definition pertaining to the term, the definition terms relative to the highway design are given in the list of the definition presented with this manual, the AASHCO. As part of the specific procedures described below, access to highways, any access to highways existing or proposed public highway that which needed to provide the highway transportation services from the public with a private installation suitable to transportation facilities. Installation highways. Installation highways include all the roads and streets within sight limited and public and private installations. Highway planning. The planning of the general road system is an integral part of the public and private installation master planning. The major objective of the master planning and the group that relay the functions reasonably close to each of the interrelating land use area with the maximum efficiency speed of the construction and economy of the operation. Connection to road system should be planned with keeping the object of the minimum travel to permit the optimum circulation of the traffic. The organization both outside within the installation and traffic studies may not be available to show with a good available judgment assessment of the current and near future needs must be made with the determine the traffic requirements. Geometric design with the highway facility should provide with the safe, smooth, and convenient traffic movement consistent with the time limitation, topographical conditions, extent of possible economical construction, existing roads and street installation could be classified in accordance with the requirements of the presented tables 1, 2, 1, 1, 1, and 1, 2, with the elements to be given in the primary with the consideration and such classification for pavement, the width of the shoulder width, the degree of the length of the slope of the grade of the passing site distance, the value of the element should be essentially greater or equal to or greater than the minimum requirements for the classification assigned with the requirement of the table 1, 1, and 2. Should be considered, but the requirements of the others should be given in greater latitude traffic. Volume of the composition of the traffic determine the geometric requirement of the roads and street, the type of the volume, character for the frequency, composition, traffic installation related to the size of the type of the purpose of the installation, size and type of the purpose of the installation. Provide information as to the function of the requirements indicating character and size of the vehicle, the type of the vehicle, the terrain, frequency you've established with the traffic classification with which the roads and street follow the classification reflecting character of the traffic that was based upon the characteristic dimension of the existing vehicles. It is essential for the designer to be aware of the vehicle traffic to anticipate prior to the selection of the type of design on the use of the particular project. Alright, the size is a little bit too small, but then it says Class B road, 2-lane roads. Yeah, the side's too slow. Geometric criteria for the classified road with open area, rural areas. Geometric classified roads, open area, rural areas. And the notes continued. Table 2 would be geometric criteria of the classified street with the build-up areas. And continued. 2. Design consideration. General geometric design with the dimension of the visible feature for the facility, such for the alignment, the size, distance, the width of the slope of the grade, with the geometric design criteria set forth in table 1 and 1 and 2, with the discuss the subsequent paragraph 2 of the 2. Road and street type of the designator of the type of the highways are generally typed according with the number of the traffic lanes, single to 2 or 3 lane, with the undivided divided with the multi-lane 4 or more traffic lane highways. When information is available, the relative of the volume, composition, traffic terrain, with the type of the terrain, with the purpose of the proposed highway, type of the required, with the readily determined by the coupling of the traffic volume and the expected on the purpose of proposed roadway or street, with the design hourly volume shown in table 1 and 1 2. Single lane roads. Geometrical design criteria for the single lane roads are shown in the table 1-1 and under Class E railroad mountainous where shoulders are not sufficiently stable with the permanent all-weather use. The distance between the intersection greater than 1/2 mile of the turn-ons will provide with the 1/4 inner intervals used to occasional passing with the meeting of the vehicle. Single lane pavement may provide with the fire lanes approach to the driver drives to the buildings with built-in areas. In which case, the pavement it will be at least 12 feet wide in all cases. 2-lane road streets, Class B and the D and E, the rare roads, bulk roads and streets remain with the installation 2-lane highway. These include the B Class B, D, and E roads and Class B, D, and E streets. Class A and C and F roads, road classification A, C, and F may not be used with some condition. Class B roads will be adequate traffic pattern consideration, provide criteria for road thickness for the common straight with the life expectancy of the program. The use of the 4-lane roads to be minimized with the mobilization construction. 4-lane roads cannot be provided. Cannot be divided for the Class B for the criteria will be used on the road classification were reviewed light of the requirements of the determined with the requirements of Class B roads and Class D roads could be used to satisfy with the traffic range for the Class 3 roads. The single-lane roads of Class F can be easily designed with minimum Class E roads, with reducing the number of the road classification refinement with the detailed traffic flow data with a greatly reduced with a serious affecting of the development of some of the roadway systems. Multi-lane, 4 traffic lanes for the more with a highway to design criteria with the present with the here in the highways are generally applicable. The multi-lane highways so except for the passing side of the distance is not required. Multi-lane highways are designed relative to the high speed opposing traffic should be separated by properly designed mediums type and design criteria and controls. Topographically and land use table 1 and 1 and 2 set forth the appropriate design scheme for the road streets, transverse, lighting, rolling, mountainous terrain, and built up the open areas. Vehicle characters of the table 2-1 show the dimension of the design vehicle with which for the geometric design criteria presented herein based on some of the vehicles wider than greater than 8.5 feet, the maximum width shown in the table 2-1 for any of the design vehicles. Traffic, the geometrical design criteria presented in the table 1 and 1-2 that have been developed the base of the horizontal requirement of the various combination of the number of the kind of the vehicles expect with the traffic stream of the general unit of the measurement of the traffic, average daily traffic, and the basic fundamental unit of the measurement of the traffic design hourly volume. The traffic volume is expressed for the average daily traffic in the design hourly volume table of 1 and 1 2 with the average daily traffic represents the total traffic volume of the year divided by 365 with the value of the need to determine the total service economic justification of the highways but an inadequate geometric design because it does not indicate the significant variation of the traffic during season, days, and hours. If the roads and streets are to be designed so that the traffic will properly serve the conversation must be given with the rush hour periods. Rush hour volume represented with the average daily peak of the hour of the base of the design hourly volume of the sum and design hourly volume is used to geometric design the limited study of the value of the traffic flow of the sum of the insulation indicated the peak of the highway frequency which peak the hourly traffic occurs. Average daily peak will become economically efficiently used the daily hour volume. The daily hour volume table 1 and 1 2 are shown with 15 and 12% respectively. The average daily time, average daily traffic. These median values selected for the Army insulation composition. Traffic on the installation road and street may consider the combination of the passenger car light delivery truck for the single unit truck for the truck combination bus for the other vehicle, the truck bus for the other vehicles have more serving operation character for the occupied with the more rare roadway space for the consequently imposed with the great traffic road with the highway with the do passenger light delivery of the trucks, the average daily traffic and daily hourly volume of the various combinations of the very clear traffic shown with the table of 1, 2, and 1, 1. Larger proportion of the bus for the truck, some of the other vehicle the present with the traffic stream design during selected design hour, the greater the traffic load of the highway capacity required with the daily hourly daily hourly volume table of 1 and 1 2 to diminish each for the highway class with the percentage of the bus trucks, traffic vehicles, and traffic stream increase the table to provide with the design data containing 0, 10, 20, and 30% of the above the truck and some other vehicles. Alright, this is a table of design vehicle dimensions. 2-4 speed with the capacity of the influence. Speed, the influence of the geometric design varies. Speed according to the physical character of the vehicle, the highway traffic, weather condition, volume of the traffic type of the show of the other roadside feature of the on street, with the speed with the generally with the design. Depending on the traffic control of the device, the width of the weather and traffic conditions are variable on the road. The physical feature of the roadway usually control speed, but the other conditions are variable there. Therefore, the speed of the positive control of the geometric design considered the must be given the selected design speed and average running speed if the adequate design are to be developed. Design speed. Speed selected for the design with the major control of the design physical feature for the highway, the physical, practically although the feature for the highway with the assumed effective the sum of the extent of the design speed with the maximum of the curvature super elevation might side. Minimum sight distance for the automatically determined with the selected design speed with the other feature for the pavement and show with the later clearance for the obstruction that are not directly affected by design speed with the due effect of the speed vehicle speed with the if the design speed with it should be selected for the primarily the base for the terrain character for the land use economic consideration geometrical design criteria presented here and are by design speed shown with the name of the design controls table of 1 and 1 2. Average running speed with the average running speed on which of the geometrical design criteria are based on shown with the design controls table of 1 and 1 and 2. Capacity condition, the effective capacity of the road and streets will vary with the lane width, distance with the lateral obstruction condition with the width of the shoulders, profile alignment with the composition of the speed of the traffic factor of the relay of the referred to collectively with the prevailing condition with the factor of the depending on the physical feature of the highway with the call of the prevailing roadway condition with the depending on the characteristic of even the traffic with the call of the prevailing traffic condition with the term of the capacity of the itself has no significance unless all the prevailing roadway traffic conditions are stated. The capacity analysis, capacity under Her ideal condition of the present with the TRB highway capacity manual with the uninterrupted flow capacity for the owner for the ideal traffic roadway conditions, two-way, or highway total both lanes, multi-lane with the average per lane with the direction with the heavier flow will be 200 passenger cars per hour. Capacity uninterpreted flow with the daily hour volume shown with the table of 1112 with the are equal to the capacity of the uninterpreted flow of the each for the cloud for the road and street with the base of the geometrical design. Criteria presenting highway capacity is directly related to the average running speed with the maximum capacity occurs when average running speed is between 30 to 45 miles an hour, the fact of the increase of the average running speed will also reduce the capacity to the daily hourly volume of the shown on the table of 1 and 1 2 for the Class B roads, Class B, D, and street will reduce the accordance for the following tabulation in all cases the anticipated the average running speed with the subsequent length of the road and street with the appreciable length of the less than 30 miles an hour, shown for the average speed of 30 miles, 25, and 20, and 15, and percentage values shown on the table of 1 and 2, 100, 95, 87, and 72. Geometric design for the road and street with the cross-section element, the pavement, the type of the strip of the pavement, the type of the sum of the import, and factor geometric design have the ability of the pavement, the surface of the retained shape of the dimension for the cross-section, possible effect of the pavement, the surface of the driver's behavior, should be considered for the geometric design. Normal cross slopes. Selection of proper cross the slope of the depends upon the speed, curvature, relation of the vehicle, character of the car, requirements general, the weather condition, cross slope of the sharp curves, super elevation discussed by the ASHTO G2, cross slopes of the tangent of the flat curves are shown in the table 1 and 1 2 with the 1 and 2 more lines inclined with the same direction from the Class B road with the each and streets. Each successful line outward with the crown line should have the increase of the cross slope of the lane adjacent. The lane adjacent to the crown line shall have the minimum cross slope of the table is 1 and 1 and 2, but the cross slope of each successful line should be increased with 1/16 of an inch foot. Where pavement is designed with the barrier curves, the recommended with the minimum cross section with 3/16 of an inch foot for the BU of the Class B roads and streets. Minimum cross slope of the 1/4 inch foot may be used for Class D and E roads and streets. Lane width, the number of the widths of the traffic lanes shown on the table of 1 and 1 2 for the minimum considered with the adequate accommodated with the indicator of the design hourly volume of the traffic composed principally with the wheeled vehicle whose overall of the width of the 8.5 feet or left. The traffic wide traffic lanes are required with when traffic is composed with a significant percentage of the vehicles where it goes over with a greater than 8.5 feet. In general, the lane with the width with the concrete except for the width of the largest oversized vehicle, the vehicle designed for the 8.5 to the nearest high even foot of where such traffic is anticipated with the curbs, the combination of the gutters, curbs, gutters and paved gutter for the attentive of the storm drainage facility will not be considered to do during the mobilization situation unless the determine the absolute necessary for the condition would, although their construction of the road and street with the design will account for the no curb feature for the provided with the drainage and erosion controller accordingly. Curbing construction in the built area with the curb and the combination of the curbs of the gutter for the paved gutter for the tendon with the underground storm drain system will provide with the necessary along the street with the open and storage areas is required to aid with the collection with the disposal of the runoff, then cool with the snow melt with the control of the erosion with the control. Confined traffic is required with the extension of the similar facility with an open air with the combination of the gutter that will not provide along the except when necessary with the steep of the grade with the controlled drainage to prevent erosion with the shoulder fill slope with where such facilities are required. They should be located outside of the edge of the traffic lane. Should be either the mountable type with a suitable outlet for the tendon of the drain pipe with the paved gutters. Also shallow channels extend with the cross of the roadway shoulders down with the fill slopes. Classification and type of the curbs classified with the barrier with the mountable with according with the intended to use of the barrier curb with the designs to prevent and release of the discouraged vehicles from running off the pavement. Therefore, they have steepening slope with the face with at least 6 inches high. Mountable curbs are designed to allow vehicles to pass over the curb without damage for the vehicle. They have the sloping further 3 to 4 inches high. For construction purposes, the curbs are usually designated with a combined curb and gutter with the internal curb. Integral curb and gutter for some of the installations. Curbs are divided into 4 types of the conveniency with the reference for the type 1 with the combined gutter section with the barrier curb, type 2 with the combined gutter section with the mountable curb, type 3 with the combined gutter with the section with the offset barrier curb, type 4 with the barrier curb and integral with the pavement slab. The curb shall be placed with the undesirable subgrade with the subgrade compact with the same density as the subgrade adjacent to the road. Location for the regard for the lane width. Type 1, type 1, 3, and 4 barrier curbs are necessary for the offset of the barrier curbs with the sufficient distance to the edge of the nearest of the traffic lane with the prevent the reduction capacity of the curb offset of the traffic lane width of the glass roads with the street within design with the barrier curbs are shown in table 1 and 1 2. Type of the tubes cover the mountable curb that cause very little, if any, of the lateral displacement of the traffic adjacent of these curves, therefore it is acceptable to locate type 2 curbs at the edge of the traffic or parking lane. Road streets and appendages. Shoulders width of the shoulders width should be stated with the table 1 and table 2. Shoulders of the road, roads of the rural are normally designed without curbs that require the width of the shoulders to accommodate high traffic volume with geometrical design criteria for the shoulder that represented and presented with the table 1 1. Shoulders for street, the general rule of straight and city, they're designed some of the type of the barrier curb, but do not require the shoulder except where needed. For lateral support of the pavement of the curb structure, for the lateral support is required, the shoulder should be at least 4 feet in the width, but where feasible, when the other section within builds up an area for the design of the streets without curb area curb with the geometric design criteria presented on the table of 1-2. 332 medians, uses where the traffic volume of the crowd with the construction multi-lane highway, the opposing traffic will separate with the medians. Medians should be highly visible both the day and night, but there should be the defined color and contrast between the median traffic lane. Paving absolute minimum of width of the median is 4 feet, with the desirable minimum width is 14 feet. Types. The cross-section of the medians illustrated in Figure 3.1, but is not with the necessary for the median to be uniform throughout the length of the divided highways. 3.3.2.3. Curbs. All design criteria relative to the curbs presented herein are applicable to median curbs, guardrails, and guide posts. Used for the safety guide for the traffic, the guide posts should be provided at all of the locations along the roadway when the driver is to be confused with the particular area at night, as of the direction of the roadway along with the roadways is subject to the periodic flooding along with the roadways where fog exists. Long periods of the time when the driving off the roadway with prohibited region with other than safety guardrails are normally required at the location where the vehicle accidentally leaving the roadway might be damaged with the resulting injury. Occupants of the guardrail, the guidepost should conform with local highway department criteria. So the curb and crown paved, type A and B and C, and then the curb, crown, and turf provided with a 6 and 15 foot curb and depressed turf cover with a note 3 with a minimum 10, 25, and 40 desirable note 3. Note 3, minimum 1640 feet and more desirable shoulder strip note 3. And then, curbs are paved median with the B monolithic is shown with the 1B with the maybe the strip with the mound with the monolithic pavement as in 1C with the strip with the mound with the curb median with the slab with the must be anchored with the brown with the pavement. 1C, all medians less than 10 feet wide with the strip with the design with the barrier curb with the vegetation is maintained with the median with the snowfall. Snow removal will be required with the minimum width of the median should be 10 feet, with the separating with the guardrails will be insulated with the median for the justified with the traffic conditions. Where depressed medians are used with the 4-lane highway with the opposing lanes with the utilized with the standardized class B2 lanes of the road design. Alright, let me turn this the other way. Alright, this is the design criteria for the guardrail for the guideposts and the side slopes. Here for the guideposts only on the slope of the initiated with the guardrails if the initiated medium slope with the class B with the roads and street with the 2-to-1 with the front slope with the cut with the 15 feet with the less than height with the 1-to-1 and 2-to-1 front slope with the cut with the 15 feet and a half 1-to-1 2-to-1 back slope with the cuts and the 2-to-1 front slope with the fill with the 20 foot or less height with the 1-to-1 2-to-1 front slope within the fills within 20 foot in height. Minimum slope of the class D and E of the roads are 1-to-1 2-to-1 front of the back slope within cut with the 1-to-1 2-to-1 front slopes on fills. Use the guardrails on with the minimum slope of the class B with the roads and street with the front slope with the cuts for the 10 feet with the left with the height with the 2-to-1 front with the slope of the cut between 10 to 20 feet in height 1-to-1 1 to 2-to-1 front slope with the cuts over the 20 foot in height 1-to-1 2-to-1 back slope with the cuts with the 3-to-1 slopes of the field with the 10 foot less in height 2-to-1 2-to-1 front slopes over the field between the 10 to 25 foot in height 2-to-1 front slope of the fields over the 20 feet in height. Minimum slope of the class D with the E with the roads of the street with a 1-to-1 2-to-1 front with the back slope of the cuts, front slope of the field with the U of the guideposts on. Minimum slopes of the class B with the roads and the street with the front with the strip slope with the cuts with the back slope with the cuts with the front slope with the fields. Minimum slope of the class D and the E road street with the front slope with the back slope with the cut with the front slope is on fills. No guardrails with the guideposts required with the minimum scope, slopes of the Class B with the roadways of the 4-to-1 front slope within the cut, 4-to-1 back slope in the cuts, 4 foot less than less in height, 3-to-1 back slope within cuts over the 5 foot within height with the 4-to-1 front slopes on the fills. Minimum slope of the Class D E roads or street with the 2-to-1 front with the back slope with the 3-to-1 front slopes on fills. And it shows the tangent and the degree of the curve going from 0 to 30. And then it shows over here the height of the cut of the or the fill in feet. 33332. Design criteria of the guard with the guidepost is not normally required where the front slope of the slides, but rather are 4-1 flatter with the design criteria with determining whether the guardrail with the guidepost is required with the shown figure 3-2 with the ordinate with this figure. Designated height of the cut and the film of the feet with the U with the manual referred with the vertical distance between the outside of the intersection shoulder, front slope planes, edge of the shoulder with the toe of the front slope with the cuts on the field between the toe and the top of the back slope of the cuts. Location with respect to the edge of the pavement. Guardrails guideposts should be located with the content off the edge of the pavement outside of the limited usable shoulder with an elevation base of the 4 inch of the 9 inches below the edge of the lane pavement of the shoulder width of the shown with the table of 1 and 1 and 2 will be widened 2 feet to provide space for the insulation guardrail of the guidepost with the guardrails and alignment of the guidepost should be flared outward if required, buried on the traffic approach with the end of the taper to the narrow structure with the meet curb lines. Marking guardrails and guideposts must be highly visible, particularly with the night. All guardrails and guideposts shall be marked with the pane with the ASHCO safety requirements. Earth slope. The determined inclination of the side slope of the proper consideration should be given in the drainage of the main tip of the erosion, with the stability of the made difficult with the corrosion. Some of the soil to the steep slope of the 4 to 1 steeper if it may be impossible to control erosion and maintain vegetation control of the slope of the straight steeper than 2.1. 2 to 1. If the main to be accomplished without special equipment, the side slope should not be steeper than 3 to 1. The central side slope along the highway be flat enough for the stability under normal conditions. Design criteria for selecting earth slope is and present with a combination for the design policy for the establishing need for the guardrails and guideposts. Figure 3.2. Bridge clearing for the requirements of the effective of the highway safety are found within the AASTHCO HB 12. Horizontal, the minimum horizontal distance of the curb on the bridge of the should be equal to the width of the approaching roadway in the traffic lane of the park and the lane of the full width of the shoulder of the median of the divided highways. When the cuff of the carpet of the railing is left within the cuff of the decking of the meridian area, traffic lanes for the traffic opposed to the direction will be on separate structure for the usually more than economy to pave over the meridian area of the bridge with the median with less than about 15 feet. Vertical, the minimum vertical clearance of the road shall be at least 14 feet over all the traffic lanes, parking lanes, and shoulders. Side distance and length of the roadway visible ahead of the vehicle along with the highway term of the site distance. The site distance is divided into 2 categories: stopping site distance, passing site with the minimum stopping, and so passing site with the distance is shown for the table 1, table 1, table 1, 2. After it should be made with the provided site with a distance greater than those shown. Stopping site distance. One single lane road, the stopping site distance must be adequate to permit approaching the vehicle to each of the stop horizontal curve site. This will be critical for the each wife that require with 2 or more lane highway. Passing site distance. Passing site distance should be provided as frequently as possible as long as the two-lane roads are laying equal greater than the minimum value shown in table 1.1 should be provided with the minimum passing site distance. In table 1.1, provide the safety distance with a single isolated vehicle traveling at a design speed past the vehicle going 10 miles an hour less than the design speed. The site distance for the safe passing section should be shown on all construction improvement plan for the A with the proper marking on the sign placement. Horizontal alignment general, where the change of the horizontal alignment is necessary. Horizontal curves shall be used with the effect of the gradual change between the tangents. In all cases, if the consideration should be given the use of the flatness, curvature of the practical under the existing condition, adequate design with the horizontal curve, depending on the establishment of the proper relations between the design speed with the maximum degree of the curvature or minimum radius, the relation of the relation with the super elevation. Maximum degree of the curvature is a limiting value given the design speed vary with the rate of the super elevation. Side friction factors. Maximum curvature of road is desirable with the absolute value of the design. Horizontal curvature of the super elevated roads are shown in table 1.1. The absolute maximum curvature for roads without super elevation is the same as shown with the streets with the normal crown section in table 1.2. Streets absolutely maximum value of the degree of the curvature and streets with the built up areas are shown in table 1.2. The absolute maximum values are given with the streets with the normal crown section, no super elevation, super elevated section. Super elevation, practical super elevation rate together with the shape side with the friction factor for the determinant of the maximum curvature of the super elevation rate with the side friction factors depending upon the speed, frequency, amount of the precipitation, type of the air with the built up, the open with the super elevation rates will be determined in accordance with the ASHTO GD2. Widening of the roads and street of the pavements of the road on straight, while widening to provide operating condition for the curve comparable to the tangent. Widening is necessary within a certain highway curve because the long vehicle will occupy with the greater width of the rear of the wheel with the general track inside of the front wheel to add with the pavement necessary can be computed with geometry with the aim of the combination for the curve of the wheelbase. Generally, with winding is not required with the modern highways within 12 feet of the lanes. High type alignment, but some of the combination speed with the curvature with it may be necessary for the widen. These highways also have the amount of the widening required on the horizontal curve on the roads are shown in table 3.1. This is the widening normally required with the off track with the main out with the provide clearance with the rear side with the restricted addition with the width should be added with the inside with the curve of the charting at 0 with the at the tangent spiral with the maximum at spiral curve with the diminishing of the maximum of the curve of spiral to the 0 with the spiral tangent is shown in figure 3.3 with the increase of the sight distance may be provided with additional widening of the removal of the sight obstruction. Later is normally recommended to cover the generally more economical figure 3.4 with the show of the relation between side difference along the center of the line inside line of horizontal curve with the distance for the sight obstruction located within the inside of this curve. The clear side difference along the center line with the inside of the line lane with the horizontal curve should equal the minimum stopping sight distance in table 1.1 for the design speed. Alright, vertical alignment and grade with the design with the vertical alignment involved with the establishment of longitudinal grade and slope of the road with the streets and highway with the key conservation, determine the grade with the speed reduction, maximum grade with the drainage for the minimum grade, determination with the maximum grade with the maximum allowable grade with the depending on the length of the grade, and sustain with the critical length with the grade is the design distance design vehicle with a 40,000 pounds gross weight, 100 horsepower engine can travel up to designated grade before the speed with the reduced below the acceptable value with the usually 30 miles an hour. Critical length with the grade they're shown the table of 1, 1, 2, 1, 1, and 1, 2. If the grade exceeds the critical length, highway capacity is reduced and left for the climbing of the lane is added with the heavy vehicles. Determine the minimum grade table of 1, 2, 1, 1, 2. Give the minimum grade where adequate proper drainage curves. General vertical curves should be provided at all points on the road street where they chain with a longitudinal grade of the major control save the vehicle with the operation of the vertical core and site curves and sight difference and sight distance should be used as long as possible economical feasible minimum sight distance required with the safety must be provided in all cases. Vertical curves may be any one of the type of the simple the parabolical curves shown in figure 3.5. There are 3 lengths of the curves and vertical with the curve the maximum length of the required safety minimum and all vertical curves should be as long as economical feasible minimum length of the vertical curves also shown in the table of 1 and 1, 2. Cross section figure 3.6 and 3.7 illustrate the typical combination of the cross section elements with the geometrical design criteria outlined in the table of 1, 1, 2. Other combination of these cross-section elements illustrated in AASHTLGU2. Alright, roads, normal crown section with the typical roads type with the normal crown crossing section with the figure 3.6 with the compromise, so-called streamline cross section with the shoulder edge of the channel bottom with the intersection of the slide slope with the original ground with the round with the simplification maintenance with the appearance of the on the road with the air open air with the round with the shoulder edge with the will be restricted to 3 to 4 feet wide at the intersection slope steeper than 2 to 1, 2 to 1. Only slight rounding will be used at the intersection slope or at flatter than 2 to 1 or 2 to 1. And then show the widening of the in feet with the for 2-lane preventing on curve of the width with the pavement of the tangent bull of. And then show the degree of curvature and then the speeds. Your tangent transition symbols for method layout, widening and super elevation spiral lanes. Sight distance, highway, inside lane, line of sight with the side of obstruction. Your max degree of the curvature center line over the inside lane versus the middle ordinate center lane and the inside lane to the side of obstruction in feet. Crest vertical curves, type 1, type 2, type 3, and type 4 sag vertical curves. Super elevated section, figure 3.6 show of the preferable super elevated cross section of the road of the army insulation, low side of the cross section, similar to the normal crown section, except for the shoulder slope of the low side of the section of the same of the preventing pavement the super elevation, except for the normal slope of the grade of the on the high side of the super elevated section with the algebraic difference of the cross section, slope of the pavement, the edge of it should not exceed the 0.07 of the vertical curve should be at least 4 feet long, at least within 2 inches inside 2 feet of the shoulder should be held on the super elevated slope. Street typical street type of the cross section without parking are shown in figure 3.7 of the geometrical design with the various cross section elements shown in favor presented in table 1, 2. Intersection criteria. General the practical all highways with many insulation with the intersected of the grade with the normal design with the conservative only playing the unused sign signalized intersection normally close to the way space with the regular intervals. Long street with the build-up area with the capacity with the street with the in most cases be with the control with the intersection capacity. Design criteria, geometrical design criteria with the inspection are presented with the AASHTO GD3, GU2, and SR2 and the TRB highway capacity manual. Alright, let's turn this sideways. Alright, show the maximum right away with the varies with approximately with the 60 feet with a single lane with the class E with the roads approximately 250 10 feet with the class B with the multi-lane on the C note 1. Minimum of 20 feet with a 5-foot variable C with the note 2 with the variable T with the variable C note 4, C with the 3 S C with the note variable note 2. Minimum 20 foot normal cross slope C table to 1, normal cross slope C table to 1. 1 mat normal across slope with the shoe with the table of 1, 1, 3 to 4 foot rounding with a 2 to 1 FS flat site rounding of the flatter F5 rounding and rounding normal crown. Super elevated minimum of the 3 to 4 foot rounding of the 2 the FS sliding rounding platter rounded variable C note 2 natural ground variable C note 4 variable C note 2 minimum 2 feet. Minimum 20 feet parabolic curve of the minimum of the length of 4 foot alternate FS and MS rounding. Alright, then show the curb no parking, industrial frontage page, normal cross slope, normal cross slope. Then show the curb with parking lanes. Kind of got to pee, so I'm hurrying up here. Or represent the installation area with equivalent design with the criteria area of the variation evidence intersection. Capacity 1 to 2 with a two-way street without subject with a fixed time with a signal control with the shown with the general type of the area with the site within the site city with the TRB highway capacity of the manual. The curve of the U with the particular location for the typical installation should be selected with the base of the similarity with the type of the area with the indicate with the TRB highway capacity manual. Following tabulation indicate with the area with the intersection curve with the should not normally used. Area with the design U with the highway capacity of the downtown central portion of the built up of the area of the major installation fringe and business district with the equivalent area of the central portion of the built up areas are to be all major installation industrial surface the warehouse the area of the major installation outlying business district intermediate residential proportion built up the area of the major installation industrial surface warehouse residential portion of the built up area of the immediate installation, all built up area of the small installation located with the shopping center, the community center, with the community center, with a similar area with the public assembly is open to the area, isolated road intersection, open areas, rural TRB highway capacity manual. Capacity with the intersection, the capacity with the daily hour volume shown in the table 1 and 1, 2 with the free flowing highways without the intersection on the grade of the free crossroad with the minute minor traffic. These highways have no traffic control signal with the intersection plane. Unsignalized intersection capacity is effective with very little uninterrupted flow with assume the AASHTO of the procedure suggested the guide with the design of the intersection. So if the suggested design hourly volume combination with signal control should be assumed with the geometrical design intersection, 2-lane through the highway crossroad with a minimum two-way daily hour 400, 250, 400, 250, 500, 200, 650, 100. 4-lane through the highway crossroad, minimum two-way daily hour value. 1,100, 1,550, 2,025. The tabulation may serve as a general guideline of design. Out of graded intersection with the following manner with the daily hour volume of the traffic generated intersection approximately equal less than shown in the tabulation capacity through the highway based on the daily hour volume shown in the table 1, 1, 2 with no intersection with the capacity of the analysis. Crowded department the daily hour volume of the traffic grade within shown with the tabulation of the intersection should be designed as if it were under signal control of the geometrical layout should be made with the conjunction of the intersection capacity and analysis for the highway capacity manual. Volume shown with the tabulation have no relation warrants of signalization or any of the indicate whether or not the signalization should be used warrant for the traffic control signal or given the ANSI D61 set 1. Intersection curve with the minimum edge of the pavement is designed with the necessary to provide the minimum space with the turning with the vehicles. On signal line with the grade with the intersection ASHTO with the design criteria with the guidance presented with the GU with the SRT with the should be used. Minimum radius of the edge of the pavement, the design of the street intersection with the 30 feet with the required with the passenger for the car with the 90-degree turn with the larger radius of the should be used if any with the truck. Traffic expected with the turning speed grade within 10 miles per hour are anticipated with a minimum radius and rules intersection of 50 feet. Minimum curb radii. Minimum curb radii is normally used as a plane with the unsignalized intersection with the reduce the intersection area with the minimize the conflict between the pedestrian vehicle with the curb design should fit. Minimum turning path with the critical design vehicle with the expected within the traffic generally minimum curb radii to be used with the intersection curve that may be determined on the basis of the following information. Curb radii of 15 to 25 feet adequate with a P design vehicle that should be classified in Class D East cross street with the practical no single unit with a truck with a WB 40, WB 50, WB 60, semi-trailer combination trucks. Design vehicles are expected with a major intersection where parking is permitted with the both intersection street with a radii of the 25 street with a provided on all new construction on reconstruction where space is available. Curb radii on 30 feet or more shall provide all major highway intersection accommodated with occasional truck in the traffic. The table 121 with the minimum turning radius. Radii with 40 feet for the problem 40 feet or more, preferably 3 cm with the compound curve with the path of the critical design vehicle is expected with the traffic. Should provide where SU WB 40, WB 50, WB 60 design vehicles in turn rapidly see table 1 and minimum turn radius. Miscellaneous single signs should conform with the ANSI 061 standards. Pave the marking. Marking should provide with the paved surface as the safety measures to increase the ordinary traffic flow of the marking should conform with the local highway practice criteria. Standard requirements are provided with the ANSI 061 Uniform Traffic Control Devices. And then introduction to geometric roads and streets. That's the quiz, and that completes the reading, except for the table 1 and table 2, which I might come back to right now, depending on if I can see them. How many pages is that? Well, anyways, they're available. Introduction to geometrical roads and streets.